Advanced Lesson 9, Triangles. I'm chilly. Enough said. Let's get on with it. Well, actually, let's not get on with it. Let's talk about likes. I got quite a few more likes for this video than, by this video I mean Lesson 8, than in previous lessons, so I'm glad about that. Thanks for everyone who clicked the like button. I'm happy that my shilling and self-promotion has paid off. Shameless self-promotion, actually. Now, let's have another installment of Chili Done Fucked It Up, because there's a couple things that we did in the last lesson that I'm not happy about, and I'm quite disappointed that you guys did not speak up and stop me from doing this. That being said, let's fix it. So we made this nice template function here, calculate intersection points. And we made it templated, but then we proceeded to make it all in float, which is dumb because that's not guaranteed to be the type that we're working with. We should have been using T for all of these things. So let's quickly go in here and replace float with T in all of the instances in which it appears. I see, it's funny, I put the T in front of the 0.0. I forgot to change the floats. Oh well, shit happens. So there you go. So now our calculate intersection points should work equally as well for doubles as it does for floats, which is what we were aiming for in the beginning. Not that we'll be using doubles, but you know, it's the thought that counts, really. Next, let's go to rect, because it is rect. Specifically, the contains member function here. So py greater than top and py less than bottom, good. Px greater than left and px, oh, okay, that's fine. Okay, so there's nothing wrong with this. I'm just going insane. Good to know. Well, at least that's crossed off the list. Let's look at the drawable constructor and let's see if I'm going insane here. No, this one's fine. Okay, so we got a problem here. And it's not immediately clear, but this negative int max, negative int max here, we're specifying the maximum range of integers. So basically we're saying we do not want to clip, which is the default clipping state, no clip. Except that it doesn't actually work because we're specifying these integers, but we're converting them into floating points. This is a rect f. And when we do that, dumb bullshit happens. Let's take a look at this dumb bullshit. Let's put a breakpoint here. And let's make sure we're in debug build. Let's run the program. So here we've got our drawable. And we're not getting anything here. Clip this. We're just getting all question marks. That's not good. Well, that's just because it hasn't actually run the constructor yet, I'm hoping. Let's step out of the constructor. And that should mean that the parent, which is the drawable object, should have been constructed now. Maybe. Yeah, that's what happened. Now let's look at this. And we'll look at the drawable object. And what we see here is... okay, so this works fine too. Well, fuck me then, because I thought that when you can... oh, okay, no, this is not the point at which things fuck up. The point at which things fuck up is when you try to convert these numbers back to integers. What you get is they all turn negative for some reason. It's a dumb thing about rounding errors and the maximum that you can have in an integer. And what basically happens is these all convert back to negative about 2 billion. And that means that you just clip everything out and everything disappears. Don't want to work this hard to show you guys. So if you really want to investigate, you can investigate yourselves. But what we're going to do here is we're gonna... Okay, I'm just gonna show you guys in a really dumb way how this works. We're gonna go int. So we got top, bottom, left, right. So int top is equal to clip.top. And this will convert it into... That's not a function. That'll convert that into an integer. And we're just going to see what happens when we convert. And you'll see how fucked up it is. Bottom, left, right. And no, I did not forget the other ones. I'm just setting it up. Left. Did I copy that? Yeah, I did. Right. And we'll put that there. Now, all we got to do is put a breakpoint here. And we'll run this debug again. Yeah. And then we'll say, where's my fucking Windows, bitch? We'll do locals. And here's what happens when we convert back from our floating point values back into integer. So the first one, -2 billion, that's about right. The second one, bottom, is also -2 billion, meaning our rectangle is non-existent. And this one's also -2 billion, and so everything, the rectangle basically scrunches up into one infinitesimal point and clips everything the fuck out. So yeah, converting from the maximum integer into float and then back into integer is not a good thing. This is what we learned. What we're going to do is, well, the negative integers are fine, so we'll leave them like that. The positive ones, they're kind of fucked up. So we're just going to back it off a little bit. We're going to say, okay, we'll take the maximum and then we'll back it up about 2. This is kind of ghetto, but fuck, man, it works. These are the problems that you run in with when you start fucking around with floating point numbers. But that's the road we chose to take. No turning back now. We could turn back, but I don't want to. So I fucking closed. I just have no more words because I did this before and it worked fine. I think I like subtracted 10 from it and it was like, that's good. That's good. You're bang on. So now I just think there's a conspiracy. And I don't like it. Okay, that worked. So subtracting 100 was working. And it's a little, it's not perfect or anything, but shit, it works-ish. It works-ish. So yeah, there's probably a better way to handle this, but I don't care. And I'm really salty now that took that much time because I wanted to get this video done in under an hour and I've already taken like 12 minutes. It's fucking pissing me off, man. It almost makes me want to start this over again, but I'm not gonna because I got things to do. So that's fixed. Now this will work properly. For all of you, none of you who were, for whom that was keeping you up at night. I'm pretty sure that sentence wasn't grammatically correct, but fuck it. Because that's all the chili done fucked it up stuff that I've got to cover now. So we're done. Also, this is annoying. Why are you expecting shit? It says it's succeeded. I fucking hate you. Autocorrect compiler thing. Because yeah, okay, that bullshit's gotta stop. That's what I'm trying to say. I'm not gonna take your shit anymore, compiler. Let's get on with it. So, what do we want to do? What is the thing that we want to accomplish today? Where do you want to go today, Microsoft? Okay, so no, wait. Let me go back. Let me start this at the beginning. This is what we have. This is what we got. It's like a bunch of lines and And it's good, but it's... when you got so many lines, it's hard to figure out, you know, what's on the inside, what's on the outside, what's on the flip side. What you want to do, what I want to do, is I want to make those lines fat. That is P-H-A-T, fat. And what that will do is that will make them, I don't know, it'll make shit look better. And that is a major concern of ours, making shit look better. So how are we gonna make these lines fat with P-H-A-T? What we're gonna do, let me get my drawings out here. Why did that? Okay, that's fine. Let's get our thing here and fucking Photoshop busting my balls. Okay, I'm gonna make this not so fat. And there we go. Okay. So how do we make shit fat? Well, we could say, okay, so we want to draw fat lines. So what we're going to do is we're going to draw a bunch of skinny lines side by side, thus making one fat line. No, that's dumb. You probably could tell even before I finished that little spiel of mine that was not the way we're going to do it. So you could say, okay, well, when we drew a filled-in circle, what we did was we went inside a rectangle, and for every point, we checked if it was within a certain distance. And if it was within that distance, we filled it. And that's how we're going to draw a circle. So we could do that for the line, right? We have the center of the line. We check to see if the distance between the point and that line is within a certain amount. And if it is, we fill it, and that will fill in, you know, a fat line. P-H-A-T. But that's not how we're going to do it, because that is also dumb. This is also dumb too, but I did it because it was super easy. So how are we going to do this? The answer is, well, let's say we've got this box and we want to create a fat line. We want to draw this box with a fat line. What we do is we do something like this, We divide this into polygons, and then we draw those polygons. Because drawing polygons is how we draw shit. Now, how are we going to draw these polygons? Well, here's the thing about drawing polygons. The more sides you have, the more shit gets complicated. Not complained. It's complicated. Shit gets complicated, right? More women, more problems, right? More sides, more problems. That's what hip hop culture has taught me. And also, this is pissing me off, so I'm gonna move that there. There we go. Gotta be able to see my notes. So, I'm just reading now. Can't talk while I'm reading. That doesn't work. Right, so what do? We break up complex polygons into simpler polygons, like this, and maybe like this, and maybe like this, like that. So what do we have now? Well, now we have triangles. Triangles happen to be the simplest polygons that there are in the land. So we want to break everything up into triangles and then draw the triangles, because that would be the easiest thing to do. This is a very common trope in programming. If you have a complicated thing, you break it up into simpler things and then solve those simple things individually. And triangles are the simplest polygons that we have. So we're going to draw triangles, and that is why we're doing triangles today, roundabout. Actually, I wanted to do triangles, and then I just made up a bullshit reason, because triangles are really important. All 3D graphics, triangles, it's all just triangles. So, here's the thing about drawing triangles. In general, triangles are going to exist in some kind of like mesh form. I'm going to draw some meshes here. So here's triangle meshes for you. There we go. So here is, oh, I gotta put one there. There we go. So here is a mesh of triangles, and they share a lot of vertices and a lot of sides. Now here's the deal. You're going to fill in these triangles with colors. So that's fine. But the question is, on the edges, which triangle fills it in, right? Do they both fill it in which case the triangle that is drawn last will be the one that wins and gets the edge. If they both don't fill it in, that's really dumb, because then you're going to have like cracks in your mesh, and that's never good. And I mean, if they both fill it in, then you're drawing over the same pixels twice, and that is bad from just a whole bunch of different perspectives. So, how do you determine? It's a very important question, determining which triangle will win in this case and draw over the line. And the answer is, you have rasterization rules, and they determine, let me think here. They determine when you're going to fill in and when you're not. Now, Direct 3D apparently uses top left filling convention. So pixels on the top, pixels on the left are filled in, on the right not filled in. So in that situation, red would fill it in. Wait, did I say top left? Okay, so red wouldn't fill in, and red would not fill in, and green would fill in on this side. So this side would become green. It's all green. And so forth. So that's one thing we have to take into consideration. Filling conventions when we're drawing our triangle. Fill rules. Okay. So let's talk about how we're going to approach filling in a triangle. So just like we did before, when we broke up a polygon into triangles, we are going to break our triangles up into simpler triangles, because there are different kinds of triangles. Triangles have different flavors, different races, if you will. I don't want to be a triangle racist, but it just happens that not all triangles are created equal. Here's the deal. You've got flat top triangles. That's triangles where you can't tell because I kind of fucked it up. But if this is P0, P1, and this is P2, you have it where P0y is equal to P1y. That's a flat top triangle. Similarly, you can have a flat bottom triangle, which is P1y is equal to P2y. Or you can have a general triangle where none of the y's are equal to each other. Here's a nice general triangle for you. Here's another one. And general triangles have two different flavors as well. They have a major left and a major right. So the major is the line that goes from the very top vertex to the very bottom vertex. That's the major side. And the minor side, has to take a little detour, right? So we got major right triangles, major left. So this is general triangle, and these are flat triangles, which are specific. Now, when you're drawing a triangle, a flat triangle is easier to draw than a general triangle, because you just start from, let's say, P1 and P0, and you just march along these two lines, and you fill in the scan line along here, and then you're done. Or you start at a single point, and then you diverge like this, and you fill in the scan lines. Whereas with the general triangle, you start here, and you start, diverging and filling in, and then you get here, but you can't keep going this way. You've got to now change directions on your minor side and keep going along. So what we're going to do, and what is often done, is we're going to take a general triangle and we're going to split it up into a flat bottom and a flat top triangle. and then draw those two separately. So just as we did with splitting a polygon up into simpler triangles, we're going to split a general triangle into simpler special triangles, or flat triangles. All right. We're just tearing through the stuff now. Yeah, that's good. That's good. Now there's one little pitfall. And this is a pitfall that I fell into, and it took me actually a little while to figure out what was going wrong. I was pulling my hair out, and I was swearing profusely. I was using what you might term impolite language. So let's go over what the problem is. So we got a general triangle. I managed to draw that fairly well. And so how are we going to tackle this? Well, the first thing we do is we sort the vertices. So this is going to be P0, P1, and P2. So P1 is going to be in the middle. So what we want to do is we find the equation of the line from P0 to P2. And then we find the point on that line at P1y. And we'll call this point Q. And the Q point is going to be the separation point. And once we divide this triangle into the flat bottom and flat top triangles, then we send them off to, draw flat bottom. Flat bottom triangles make the rockin' world go round. I think you guys know that one, right? And so we're going to draw this one with, let's say, P0, P1, and Q. And then we draw the flat top. And we'll draw this one with P1, Q, and P2. And that seems to work fine, except that it doesn't, and it fucks your life over while you're trying to figure out why the fuck it's not working. And so let's see why this doesn't work. The problem is once you go to draw these two triangles, you're gonna have to calculate the slopes, two slopes, right? The P0, P1 line slope, we'll call that M, and you're gonna have to calculate P0 Q, the slope for P0 to Q, and you use that to draw your lines, to find the endpoints of your scan lines, and then you fill them in. And here, you're going to go P1, P2, your slope there, and Q, P2, or P2, and your slope. No, I'm just fucking it up now, aren't I? Good job. All right. And here is the deal. Q is on the line of P0 to P2. So theoretically, this slope should be identical to this slope. Except that, because floating point numbers try to fuck you over as often as possible whenever they can, your calculation of the slope between P0 and Q will generally be different than your slope between Q and P2. And in being different, that will be able to fuck you over sometimes. How is it going to fuck you over? Well, let me just show you quickly. Let's illustrate. These two slopes are different. And then you've got another triangle. Let's say you've got a nice flat top triangle. Can be drawn in one situation. And so its slope is going to be P0, P2. But now you've got your P0 Q slope and your P0 and your Q P2 slope. So sometimes the slopes will be different enough that you'll get like little pixels that'll be open up at certain intervals because it won't be drawn by either triangle. And other times you're going to have overlap between. And it's going to start like halfway through between two different triangles, and you're going to be like, why the fuck? I could see you're going to look at it and you're going to think, why is this going, the dots are going halfway along here and then they stop. And then you'll figure out, well, that's because the triangle's being split. And then you'll figure out, well, then these two slopes are different. And then you'll be, oh, fuck. So the solution, my friends, is you don't use Q very much. So instead of passing P0, P1, and Q to the function, you're going to pass the slopes. And so the function, the draw flat top and draw flat bottom, they're not going to calculate the slopes. You're going to give them the slopes. And that way you can make sure that the flat top and the flat bottom are using the same slope for the major axis or the major side. And so you're not going to have bullshit. So, yeah, that's all I wanted to say about that. So yeah, splitting it up into P0, P1, and Q, and then using the Q to calculate your slope, not a good idea. You got to pre-calculate that shit. Okay, so that is my my theory explanation spiel. Now it's time to actually get into some code. And hopefully this won't be too much of a problem. I'm thinking we can work something out here in a small amount of time. So we're going to tackle this back ways first. We're going to create our draw flat triangle functions first, and then afterwards we're going to create a function to draw any triangle, and that function will call our draw flat triangle function. Now it so turns out that we can draw our flat top and flat bottom triangles with the same function, so we're going to do that. We're going to go to D3D graphics, we're going to add a new function, and we'll make it public for now. And we're going to call it void draw flat triable. And what do we need? Okay, this is the question. So to draw a flat triangle, we're going to draw it like this. We're going to need a start Y and a start X. So float. No, we're going to need a start Y. Or Y start. Y start. Why not just give up right away? And a Y end. And that'll be our start and our end region in the Y direction. Then we need we could do this two different ways. And the way I'm thinking we're going to do it is we're going to pass it the parameters for an equation, the slope and the y-intercept. So what we're going to do, this is probably not the most efficient way of handling the situation, but it's simple enough. So we want to draw a flat top or bottom triangle. Either is not, it's not really important which. So what we want to do, let's have a flat. Fuck, that was disgraceful. Let's see if I can't get my. There we go. Draw a straight line there. I cheated. I used my cheat hacks, people. We're gonna draw this flat bottom triangle. Makes the rockin' world go round. And so what we want the start Y and the end Y. So that'll be Y start, Y end. And also we're going to have the, let's say that this is the origin. So to define, we're going to have the parameters to define the equations of the lines of the two sides. So here's one side, here's another side. So in order to define these sides, we're going to need slope. So M1, M2, and y-intercept B1, B2. Because that's how I learned it in, grade 9 or whatever math. You got your slope, you got your y-intercept, you're all set. And so we'll pass this, basically we're passing the line equations to the function and the start y and the start x. And from the start y, we can calculate x1 and x2. Fuck, that wasn't even an x, that was a 2-2. We're not doing fucking ballet here, are we, people? No, what we're doing is we're calculating our x1 and x2, which will be the same point at the point y start. And then as we march along our y's, along our y positions, we calculate x1 and x2, and we draw lines between them. We fill in all the pixels between them, keeping in mind our fill rules, which we'll get into that later when we're actually writing the code. That's the whole idea. So we need to pass y start, y end, m1 or m0, m1, b0, b1. We like to start with zeros on our subscripts. Yeah. Fuck. Okay. So, float m0, float b0, float m1, fuck you IME, float b1. And there we go. There's our function to draw a flat triangle. Well, there's our function prototype. We haven't actually written the function yet. I wish it were that easy. If programming were that easy, then, well, what I'm doing here would not be pertinent, would it? Pertinent, is that the word I'm looking for? Probably not. Relevant? Relevant's a better word. I'm going to go with relevant. Culturally relevant. All right. Good. So it likes our function prototype thing here. Let's make a function. Let's functate. I just made that word up, in case you didn't know. All right, so we want a for loop. We want to loop through all of our y's. But here's the deal. We only want, let's see, what's our fill rule? Rasterization rule. Top left. So we want to fill top. But we don't want to fill... Yeah, that sounds about right. Fill in top left. So we want to round X start, we want to round it down. Because down is up in screen space, right? Decreasing Y means moving up on the screen. So we want to round this one down. How are we going to do that? No, we don't. We're just going to... I want to cheat. I want to look at what I did before. So I used ints. Right. I used ints. Huh. We're going to use ints here too. We're going to change this to y0 and y1 for reasons. And we're going to go constant. Nope. Nope. I'm going to go int. Constant int y end equals to int y1. So we're going to convert y1 into the y end variable. And now we're going to go int y is equal to y0. Capiche? Then we're gonna, yeah. I'm just gonna go like this. Constant int y start int y0. I like that better. This is a work in progress, people. So this is y is equal to y start, as long as y is less than y end. Now here's the thing about y end. We don't want to fill in that pixel. This is tricky. Right, so even though our triangle, let's say, goes down to here, we don't want to fill in this pixel. The bottom one here. We don't want to go down there. We want to end our y here. So if y is 5 point something, let's see, that's 0. That would be 0 here. 1, 2, 3, 4. 0, 1, 2, 3, 4. 5 point something. But we want ours to end at 4. Maybe like that. I'm wondering what I did in my old one, actually. In my old one, what I did. All right. Because it's y is less than y end, it's actually going to stop at 1 before y end. So we don't have to do the -1 at all. That's fine. That's good, people. All right. Now here's the thing. In my prototype version, I round to the nearest integer by adding 0.5. And I think I'm going to do that here too. Just because that seemed to work before. So we're going to round to the nearest integer. And yeah, and then we'll just go y plus plus. So here's our y loop. Now, inside the y loop, we have to calculate the x start and the x end for the scan line that we're going to fill. So what we want to do is, let's take a look at this here. We just want to do our, our standard y is equal to mx plus b bullshit here. So what I do in this thing is I just convert the y's back into integers. I like this kind of thing. So I'm going to copy that. So we have constant int x start is equal to, and this is just convert y. Oh wait, m in this case, it's going to be x is equal to ym plus b. So m is going to be the inverse of the normal slope, and b is going to be the x-intercept, I believe. So that's important to note. For posterity, we'll add another thing in here. And x-end. Now we got to get these numbers straight, right? We're starting with 0, so we want m 0, B0. And this is M1, B1. And again, we're going to round to the nearest. We're rounding to the nearest here too. To be 100% honest with you guys, I'm not 100% sure on when I should be rounding and when not. I just kind of throw it in there. So take this rounding shit with a grain of salt. I just do it because it feels right. But it's not that important. All right, so now we want to fill in our scan line. We have our start and our end. So we just go for x is equal to x start. That's an x. And as long as x is less than x end, x plus plus. And we just go put pixel. Well, I guess, yeah, we kind of need a D3D color. We need a color here, don't we? Put pixel X, Y, C. And we'll toggle that. Oh wait, we'll copy this D3D color bullshit. We'll put it over here. All right. Let's see how many errors we get. None. That's good. That is good news. Now let's try and draw a simple flat top or flat bottom triangle. But it's going to be hard because we won't know the slopes and everything. We'll have to calculate the slopes. But let's test it out. It's always good to test before you test yourself before you wreck yourself. It's close enough. I want to comment these, but my keyboard shortcuts aren't going to work with my recording software active. So we're going to get rid of that bullshit. We're going to create some vec2s. And we'll just do this one. We'll go 100. 100. Just going to create some test points here to work with. V1. V2. So we'll do a flat top triangle. So it'll be 150. And this one will be 50, 300. All right, there's a nice flat top triangle for us. And now we've got to calculate float. What do we want? We want to calculate float M0. Now this is equal to the inverse of the slope. So that's going to be that's going to be the run over the rise, right? So M0 is going to be, let's see here, V0. Let's get a picture. Pictures are always good. All right, so here's our screen origin. Here we've got our point V0. Here's our point V1. And here is our point, let's see, V2. Yeah. There's our nice flat top triangle. So M0 is going to be here. M1 is going to be this one. it's going to be run over rise. So the run is going to be v0.x minus v2.x. And the rise is going to be v0.y minus v2.y. All right. That was fine. Get our M1. And that's going to be... What's that going to be? It's going to be V0. No. It's going to be V1 and V2. Now we got to calculate our intercepts. Well, x is equal to y. No. X is equal to my plus b. So b is equal to x minus my. For a specific point of x and y. So we just choose a point on the line. V2 is common to both lines, so we'll use that. And so we got float b0 is equal to x, which is v2.x, minus m0 times v2.y. There's our x-intercept. B1 is also the same, except we changed the slope. All right, so now we've got our M0, M1, and blah, blah, blah. Now we can finally try to draw this motherfucker. So we do gfx dot draw flat triangle, triangle. Well, fuck me. All right, so x start is gonna be y start, v0.y. Y end is gonna be v2.y. M0 is just M0, B0, M1, B1. Color is gonna be, no, what is that? D3D color underscore XRGB. I can't remember if I had the color. Oh, I do have colors here. Well, fuck me then. White. Build that. All right, let's see if we get a triangle. Start without debugging. Do we trust ourselves? Start with debugging. And we did, and we get a triangle, and it is the mostly expected result. Now let me just have a quick close look at my screen here. Yeah, that bottom tip looks a little bit janky, but I'm gonna allow it for now because I think that's basically how it works. So yeah, that works. That's basically how we're gonna do this. But now we've got to be able to do that for any triangle, not just your flat triangles. We want to be triangle neutral here. So what I'm gonna do, I'm gonna rename this to triangle, and I'm gonna make this function private because actually You're not the people using D3D graphics are not supposed to be drawing triangles by using flat triangle. They're supposed to use the general interface function, which is going to be draw triangle. And we'll go vec2 y, let's say v0, v1, v2, and the color. Very simple, much easier to implement instead of having to calculate all your slopes by yourself. So toggle that. Well, first we'll put the N in there. Draw a triangle. All right, so how are we going to tackle this? Well, first of all, we want our triangle. We want our general triangle such that the vertices are in order. So we want V0 at the top, V1 in the middle, V2 at the bottom, because that will allow us to work with them. So first we've got to sort our vertices. So what we do is we go if V0 dot Y is greater than, how are we going to do this? V2? I'm going to do it like this. Copy my old code. Except it's all P's instead of B's. That's annoying. There we go. That's not what I wanted at all. V, oh Jesus. P2, P1. Fuck that. If V2 is less than V1 dot Y. And we'll do V, fuck that, 1, 0. Looking at this is probably gonna fuck me up, but the basic is compare the first one with the second one, compare the third one with the second one, and compare the first one with the second one. Is that what's happening? I'm getting confused. First, second, yeah, second, first, third, second, second, first. Good. I think you need at least 3 swaps to ensure that they're in the correct order. If I am mistaken, then, well, fuck me. So if V1 is less than V0, we go V0 dot swap V1. All right. If V2 is less than V3, V2 dot swap V2, because that's supposed to be 1. And that is also supposed to be a 1. There we go. And again, we have to check for this one because the second swap might have, brought another thing into the range of needing a swap. So we do V0 and V1. All right. That took longer than I would have liked. Let's continue, shall we? So first we get our vertices in Y order. Now the next thing we have to check for is we've got to check to determine if we have a flat top or a flat bottom triangle right off the start. And if we do, then we want to just draw it as a flat top and flat bottom triangle. So if v0.y equals v1.y, the top two vertices are on the same y position, then we have a flat top triangle. Draw flat top triangle. Else, if v1 is equal to v2, draw your flat bottom triangle. Else, we have just a general triangle. And in that case, we're going to need more stuff. Right, we're going to need 3 slopes and 3 intercepts for the 3 lines of the triangle sides. So we calculate those. We calculate the x position of the, okay. I gotcha. So, where's my diagram? Here we go. So we'll call this M0, M1, and M2. So the slope between V0 and V1 is M0, and so forth. And we'll calculate those slopes and then those x-intercepts for the 3 lines. So we go M0 is equal to, I'm going to go down into game, copy that, go back. That was V1 as we stated in our diagram. I'm going to copy this, paste it a couple times, make sure we don't fall into the copy paste trap of fucking everything up. So M1 is going to be V0 to V2, and M2 is going to be V1 to V2. Now our B's are likewise going to be, actually it's going to be a little bit different because we're not all 3 lines can't have a common point. So we've got to make sure that we use the right points. So B0 is going to use V0. B1 is going to use V0. B1, M1. Now, B2 cannot use V0. Let's go my diagram because V0 has nothing to do, has nothing to do with this line. Has nothing to do. So we need to use V1 or V2. I will use V1 just because. So that's how I feel at this moment in time. 1, and we have to use M2 here. So now we have our slopes and our y-intercepts for the 3 lines. Now we need to determine to figure out which slopes we use for when and where and all that happy horse crap. We need to determine whether our triangle is going to be major left or major right. And how we do that is we find the point Q, and we check if QX is less than V1X or if it's greater than. So if it's on the left side, major left. If it's on the right side, major right. That's how we solve that problem. So we go QX. Let's go to my thing here since I have this already. QX is equal to, all right, so this is not even close to the equation we want to use. P1Y. Why am I doing this? This doesn't seem like how I would want to solve for QX. Let's go back to my diagram. I gotta make this right in my own head. So we have M1 and B1, and we have V1 dot Y. Right, so if X is equal to My plus B, we want to solve for X. We want M times V1 dot Y plus B M1. V1 dot Y, B1. That seems like that's what we want to solve for QX. So we want M1 times V1 dot Y plus B1. Let's just go over that again quickly. This is M1, this is M0, M1, so B1, V1 dot Y gives us our Y. Plug that, all that stuff into the equation, we get our X. So what was I doing before? I was doing some dumb bullshit before, wasn't I? Why was I subtracting this one from this one? P1 dot X. I don't know what I was doing. I don't think it's important. I don't think we need to worry about it, because I'm doing something different this time, apparently. Well, we'll see. If this all fucks up, then I guess, fuck me, right? Alright, so now we want to check to see if we're major left or major right. So, if QX is less than V1 dot X, then we're major left. Else, we're major right. So, let's look at the case of if we are major left. In the case we are at major left, M0 is going to be M1, and M2 is going to be, or M1 is going to be M0, if that's not confusing enough for you, right? Because M0, the parameter, is the left side, M1 is the right side. Maybe I should have switched these around, but fuck it. We're down, we have crossed that bridge. And our start is going to be V0, and our end is going to be V1 dot Y, of course. So, let's do it. Draw flat triangle. V0 dot Y, V1 dot Y. All right, so the left side is M1, B1. M0, fuck, B0, and our color is C. There we go. So for the other one, that was our flat bottom part. Now our flat top half. What do we got? Oh, wait. Right. Okay. My apologies. Disregard. We've got to draw two triangles for each case. So, let's go back to our diagram here. For the flat top part, again, we want to use M1, and this time M1 and M2, and we want to go from V1 to V2. So we go V1.y to V2.y, and we want to go from M1 to M1 to M2. All right. And that is that. Now for the case of a major right triangle, let's just draw a quick thing here. Now M1 is on the right side, M0 is on the left side, right? Because this is still V0, V1, V2. Those haven't changed. And then M2 is down here. So again, we want to go... Where's my stuff? Copy this. We want to go from V0 to V1. But this time we want M0 on the left, M1 on the right. Right, M0 on the left, M1 on the right. And then down here, we want M2 on the left, M1 on the right. So, 2 on the left, 1 on the right, and we're going from V1 to V2. And that, my friends, is that. Now, for drawing the perfectly flat top and bottom triangles, we'll figure that out later. First, let's just test this out, because I'm a big fan of test. First, let's build. Flat triangle, not a member of D3D graphics. Oh, right, because I changed it. That's fine. We don't need any of this bullshit anymore. gfx.draw triangle. Why is that in there? That should be private. Why is that still there? I thought I made you private. Well, I did. Oh, wait. Okay, good. Flat triangle is private. Normal triangle is not private. That is the way it should be. V0, V1, V2. Let's switch it up. Let's put V2 first. V0 last. Gotta make sure our sorting shit is working. White. Now, flat top and bottom triangles are not gonna cut it. They will not cut the mustard, as they say. So let's what did I do? What did I do? I wasn't even looking at the screen. I was just typing. And so we go from 50 to 100 to 300. So we are not flat on the top or the bottom. Let's see what happens. Oh, and we got our triangle. First try. Gold star. Golden star for you. And what if we tried to move V0 down a lot? Let's move it to the left by 5.0. And let's move it down to, how much do I want to move it down? To 200. 100 to 175. Build that. And that also works. So major left and major right both working fine. Right, so now we just got to fix the very last part of our equation here. Draw flat triangle. D3D graphics, where is it? Where are you? Doesn't matter. Toggle header code file. There we go. Okay, so here we've got to calculate slopes, but we only need to calculate two slopes if they're flat, right? So if we are a flat, if we're a flat top triangle, all we need to calculate is the slope between V0 and V2 and V1 and V2. So we got some V0 and V2. We're just going to call them M1 and M2 just because we don't want to renumber things. And then that's B1 and B2. Right. V0 and V2, V1 and V2. And then we don't need a Q. All we got to do is 1 and 2, 1 and 2. So we find the one that is 1 and 2. And that should work. No guarantees, because I haven't really thought about it that much. Oh, here's a thing. Here's a thing you should do. You want to make sure, since we're drawing from 1 to 2, 0 to 2, you want to make sure that 0 is on the, because if they have both the same y, you don't know which one's on the right, which one's on the left. You want to make sure V0 is on the left, V1 is on the right. So you want to do if V0.x is greater than well, fuck that. If V1.x is less than V0.x, and we'll just do that. Yeah. So we'll swap those out. We want to make sure that V0 is on the left-hand side, because that's going to become M1. V0 to V2 is M1. And that's going to be the left-hand line used to draw the flat triangle. So you got to make sure that the order of your vertices are proper. And for this second one, we want to do mostly the same thing, only a little bit different. So now we want V0 to V1 and V0 to V2. So we use these ones. And these ones. And we want to sort the vertices on the bottom. We want V1 to be on the left-hand side of V2. So we go if V2.x is less than V1.x, V1.swap V2. And now we want to draw a triangle using M0 and M1. Wait, M0 is going to be going to V1. M1 is going to be going to V2. Right, so we want M0 on the left-hand side. So pick that one. There. All right. I think that is all we need to be able to draw our triangle. So let's go back to game and let's set the y's to be the same, thus creating a flat top triangle. Good. Now let's make these ones the same, making a flat bottom triangle. Also good. We have achieved triangulation, gentlemen, but we are not quite finished. There's still one piece of the puzzle that remains, and that is, of course, if we were to put part of the triangle outside of the screen, I think you can all predict what is going to happen here. Assertion failed. Abort. Abort! So we want to get some clipping in this motherfucker. What we're going to do is... we'll add a clipping rectangle in here. And that clipping rectangle is going to be... rect F clip? I think a rect I is more what we want. Rect I. That should work. I have confidence in this working. If it doesn't, then I'll change it to a non-reference. But yeah, so we want this one to be rect I. And we also want the clipping rectangle to be passed on to our friend draw. Wait, I got that backwards. I want it, doesn't matter. We want it in both, is what I'm trying to say. That's what I'm trying to say here, people. Now toggle that bullshit. Put that in there. Put that one in there. All right, so we just passed the clip on. Pass that clip on to our draw flat triangle function. So put the clip in there, we put the clip in there. There and there. So we're going to clip in here. And what we're going to do is very simple. We're going to clamp our Y start so that and Y end so that they are within the range of our clipping rectangle, and then we're going to do the same for X start and X end. We're just going to use the min maxing in this one. So X start is equal to is that going to be minimum or maximum? It's going to be maximum of Y0 and clip dot top, and Y end is going to be the minimum of this one, and clip dot bottom, but I think we have to -1 or something. Where is it? Yeah, bottom or +1. And I'm not going to question it. I'm just going to do it. Because I think that's a good idea. Basically, I think what happened was I did it without the +1, and then I realized probably better with a +1 in there. We'd try without it, but I think it's going to be dumb. And the same thing we got to do here. Max of all this bullshit. And clip dot left. And the min of this bullshit. And clip dot right. And build that. Fucking clip draw flat triangle does not take. Oh, I forgot to put it in here. Well, I apologize. I didn't see you there. But all is forgiven, or not. Draw triangle does not take 4. Okay, yeah, so we want to draw, and we want to clip this motherfucker. So we need a clipping rectangle. Port. We'll just copy port's rectangle. Obviously, later on, we're going to use this in the whole pipeline of the drawable and stuff like that. But for right now, I just want an easy fix. Cannot convert argument 4 from initializer list to rect. Okay, yeah, fine. Here you go. It's a recti for you. Uncle Mo, while you eat. This'll be a treat. And there we go. We are clipping. And now, let's do some dumb bullshit. So, vec2 mal m0 is equal to mouse dot read mouse? Fuck. Well, shit. I didn't fix this yet, did I? Shit. I can't find my... There it is. Mouse dot... get mouse Y. And... Oh, you're fucking retarded. Oh, it's because I didn't tell it that these were floats. Well, they are floats. You just can't tell. Now I gotta add 1 plus M0. That's gonna make it unhappy, isn't it? Of course it is. Copy that, that, and that, that, that. Copy this, put it here. Build. Begin. There we go. So it looks dumb, but yeah, I don't think, see, we're not getting that last line there. It's clipping it out just a little early, which is why I added the +1 before. This one's fine, but on the bottom and the right, it's clipping 1 pixel too early. So how we fix that is just like what I said before. First of all, we don't toggle that. We go here, we toggle, and we add 1. Don't ask me why, because I don't feel like thinking about it. And also, when I come up with the answer in my own head, then I have to explain it to you. So just, think about it. Talk about amongst yourselves, children. Here we go. Now we don't have that dumb problem of clipping too much. And we're not clipping too little. We're clipping exactly the amount that we want to be clipping. And that is awesome. Now let's do one more thing. Let's make sure we're not going to get any what am I thinking? Any gaps between our triangles, because that would be embarrassing. So we want a bunch of vertices. So V0. All right, so V0 is going to be, just eat a bag of dicks in hell already. V0 is going to be 50.0f, 50.0f. Be 1, 2, 3. Okay, so we'll have 4 vertices for 4 corners. 0, 1, 2, and 3 at the bottom right. So this one is going to be, I don't know, what's the width of the screen? 800? So we'll make this one 750. And then this one is going to be, why did I do that? That was dumb. I wanted to do it here. No, I want to do it here. 750. At 50, this one is going to be 550. 550. And 50. And this one is going to be... Why am I doing this? Obviously, it's going to be here. Right. Top left, top right, bottom left, bottom right. And then M is going to be in the middle. And we're going to draw a bunch of triangles, and we're going to see if they overlap or what. We can't see if they overlap. We can see if there's gaps, and that's as good. So there's going to be 4 triangles. We're going to clip them all to the same clipping region, and we are going to do, okay, V0, M0. Fuck, I'm just gonna call it M. It makes my life easier. And then V1, V2. So that's the left triangle. The top triangle, V0, V1, and M. The right triangle is gonna be V1, V3, and M. And the bottom one is gonna be V2, V3, and M. Build it. Run it. Oh, I'm not going to make it. Okay. So here we have our stuff, and it seems to be working fine. You can see if we pull it out here. See what's happening. It's hard to tell because it's all white, but I made it white because then the black pixels would show up easier. Let's make it colored just for fun. We'll do this white, blue, fuck you, red, and green. No, green. Gren. It was a character in Tobal #1. And we'll start without debugging. We'll put this one in release mode for the shits and giggles. There you go. So now you got your multicolor thing. And as you can see, we've got no gaps between our triangles. And yeah, it looks pretty decent. I am liking it. You get a weird thing happening here with the triangle drawing, but you see, you get how it works. So we've got triangles. We are triangulated, and that's good. So next lesson we'll widen the walls of the map. We'll make the walls fat, which is going to require some interesting stuff. And some of that is going to be, directly applicable to 3D topics, which a lot of you are going to be interested in. And also, it's not going to be too complicated, so it won't take another 3 hours. Good times will be had by all. But for today, I'm done. My voice is done. My pizza is scheduled to arrive within a few minutes. So I'm just going to call it the video. Thanks for watching, and if you like it, click the like button. Helps out a lot. And I will see you guys later.